students? Well, we were talking about the entire metallurgical process and we have already done with the first part, that is ores. Well, now it is time for us to talk about the next metallurgical process, which is concentration. Now, what is this word concentration? Let's understand. When I use the word concentrated HCl, what does it mean? What is the feeling it gives? When I use the word concentrated HCl, it means we have higher quantity of HCl or we have higher proportion of HCl. So please remember, whenever we use the word concentration, it means having higher quantity of the desired component. Simple. If we want the higher quantity of the desired component, what we need to do is we should remove the unwanted component. Exactly. So what is concentration? It's just having the higher quantity of the desired component. In nature, if you see, there is a substance called as ore. Now this ore has two things. First, it is having a desired metal, what we are looking for. And secondly, it is also having a lot of earthy impurities. So what we should do to this ore is we should concentrate that ore. Now when you concentrate, you will get two things. First, you will get the concentrated ore, and the next thing that you're going to get is the impurities. So what is concentration? It is just the removal of this earthy impurities from an ore to get concentrated ore is called as concentration. And this earthy impurities, which could be anything like mud, sand, silica, they are also called as gangue. So now the next thing is, how do we define the word gangue? Gangue is nothing but it's the undesired earthy impurities which are present in an ore. So all that you have to remember when we use the word concentration is, it is just the removal of the gangue or the removal of an earthy impurities, and obtaining a concentrated metal compound is called as concentration. And this concentrated metal compounds are also called as concentrated ore. Now since we know what is concentration, now it is time for us to talk about the various methods of concentration. There are four methods of concentration. The very first one is hydraulic washing, which can be done for all ores. The second one is the magnetic separation, which can be used only for magnetic ores. And the most important one is the froth flotation, which can be precisely used only for sulfide ores. And the last one is leaching, which can be used for metals like aluminium, gold and silver. So now it is time for us to pay attention to the very first one, called as hydraulic washing. As we know, hydraulic washing, the word hydra means water. So literally washing the ores with water is called as hydraulic washing. Well, it is based on a very simple principle. To understand that, let's imagine this. Let me take some metal like iron nails and let me mix it with some impurities like thermocol, and let's mix it and put it inside water. And obviously the normal observation is the heavy metal compound like iron nails will sink in, whereas the thermocol will float. So hydraulic washing is based absolutely on the same principle. It is based on the difference in gravity, or it is based in difference in density, or it is based in difference in the heaviness of the ore and the gangue particle. Since it is based on difference in gravity, sometimes hydraulic washing is also called as gravity separation. Now since we know what is the principle of hydraulic washing, this hydraulic washing can be done by two ways. First, it can be carried out in a table called as Wilfley's table, which looks like this. And another way by which we can do the same hydraulic washing is by using an apparatus called as hydraulic classifier. So first, let us see the working of Wilfley's table. Now what is a Wilfley's table? It's a normal table which is kept sloping, and this table is continuously vibrating, and it is having crest and trough, and it is having a lot of depression, which is also called as grooves. So what we need to do is, the very first thing, we will take the powdered ore particles and we will put it from the upper opening. And the next thing that we need to do is, there should be a running stream of water continuously. So the ore and the gangue particles will get washed with this running stream of water, and some of this gangue particles might go and get settled down between the grooves, which is the depression which is present in the Wilfley's table. Now as the observation is very clear, the heavier or the dense ore particles will go and settle down in between the grooves, whereas the lighter gangue particles gets washed away with the water. And in this entire process, there should be a continuous flow of water. That is what we need to remember. So this is the first method, and the second method by which we can carry out the hydraulic washing is by hydraulic classifier. And this hydraulic classifier looks like this. And obviously in this apparatus you can see there are two inlets and then there are two outlets. The first thing is we need to take the powdered ore and we need to put from the upper opening, which is called as hopper, Hopper, and then we need to pass a running stream of water from the bottom. So you're putting the ore from the top and you're sending the water from the bottom, and because of this the ore gets uniformly mixed with water and the flow of water should be continuous. So the water will rise, but that water is going to contain the lighter gangue particles which can be removed from the upper outlet, whereas the concentrated ore can be removed from the bottom outlet. The process is very simple. All that you have to remember is we are putting the ore from the top and we are removing it from the bottom. We are sending the water from the bottom, but we are removing it from the upper outlet. That's hydraulic washing, and some of the industrial photographs of hydraulic washings are these. Now, some of the MCQs that can be asked based on hydraulic washing are these. The very first one is this: the process of removing lighter gangue particles by washing in a current of water is called as we know it's called as hydraulic washing, but there is another name for hydraulic washing, and that name is levitation. So the right option over here is A. And talking about the second question, gravity separation is based upon, as we know, gravity separation is based upon the difference in gravity or difference in density or difference in heaviness. So here the right option is B.